think problem. Okay. So last time, I think in last week, not this week, we have calculated entire base share for the ESR for earthquake. So we have calculated the impulsive mode base share for the impulsive mode and base share for the convective mode. Okay, so maybe I will just open that drawing, so it will be just quick recap for that. So we are working on this. Okay, so this is the base share that we need to find out. So we, based on that, our 50% work is done. So why I'm saying my 50% work is done, because just now I know in case of earthquake, this is the magnitude or this is the base shear which is generated or which is going to act on my tank. Okay, another 50% is what? So I have to check for other loads, lateral loads. So other, apart from the earthquake, which is the other load? So obviously wind load, correct? So this is the only two lateral loads that we need to consider. So right now we are just, for 50% we have just calculated the earthquakes. Now next part will be the wind load. So basically what we need to do, we have to calculate the base shear for both. Just like earthquake, we need to find out the wind loads due to a shear, base shear due to wind load. And in between both of two, we have to find out which is governing, whether earthquake governs or whether wind load governs. You don't need to apply both. If it is fine, if you apply both, that is fine, but it is unnecessary because we always go with the worst condition. If wind load is not governing, earthquake is governing, so definitely you have to add the loads, so those will not give a uh, critical magnitude of loads. Okay, so but before analysis, we don't know whether it is earthquake govern, whether it is a wind load govern. Okay, so first we need to find out which is governing. Mostly for concrete structures, mostly earthquake load will be governed. Other, if there is any special case that like huge wind exposure area is in between that, so in that case maybe yes, we need to check the wind load case. Okay. Okay, so now how to find out the wind load? So obviously we are using the IS code 875 part 3 for wind load. So similar to earthquake, we have to put some basic parameters. Okay, so building region Pune wind zone. This is also given by earth code. If IS code, based on the location, we can find out the Pune comes under which zone. So it also gives the basic wind pressure for Pune. So that is 39 meter per second. So given by IS 875. So I have added all those pages, part number 3, appendix A, cross number this. I have attached the pages also for that. So there are also some different types of risk coefficients. So K1, K2, terrain category. What is the terrain category? So it's very simple. Terrain category means what is the terrain surrounding your structure. So if it is a flat plain terrain, so obviously wind intensity will be more because there is a no obstruction, so wind will be more. So if there is a closely spaced, obstructions will be there, so obviously there will be a wind intensity of wind pressure will be less. Okay, site class. So all this given by the codal provisions. Topography factor, so K3. So if I go down, this is the wind formula. But yes, so risk coefficients K1, how it is calculated, the temporary, whether it is a temporary shade structure, building and structure presenting the low degree of hazards. So based on that, we can find out. We have to just go through, read this description. It's very simple, and just read, and we have to just select based on that under which category our building falls. Important buildings and structures such as hospital, communication buildings, towers, power plant, and other structures. So maybe we can consider as a yes. So this is my tank is considered as a important structure. Okay, so that based on that we can maybe consider as a 1.05, and based on the wind speed also definitely you can interpolate also in between that. So like it's pretty simple. You have to just fix those values. And if you see this area A and B coefficients, 33 wind and density also given for 33 a, what is the A site class. So based on that we can fix this. So all the tables are, this is the k2 factor to obtain the design wind pressure on variable heights. So all these ready-made charts given by the IS code, so we have to just go through that, mark our interested values and come to the our wind load formula. So I will just directly go to here. So design wind velocity VB K1, K2, K3. So for Pune, it's 39. K1 is a 1. K2 I intentionally not added here, and K3 is also 1. Okay. So what is I'm getting the design wind velocity? So that is 39 into K2. Okay. So again, how to calculate the wind pressure? Suppose I want to act that pressure in my STAD. So how to find out that formula pressure? So for that, IS code gives this formula: 0.2 VZ square. It is given here. Can you see this? PD is equal to 0.6 VZ square. So that we are calculating. 0.6 VZ square is, we are getting again in terms of the K2. So K2, why I'm not adding the K2? Because K2 is varies based on the building height. So based on the terrain, based on the wind intensity, suppose my building height is at 10 meter, then the K2 is 0.91. My building height is a 15 meter, so my building K2 will be 0.97. And if my building height is 20 meter, then again this K2 value will be get increased to 1.1. So that's why, so this is the varying value. That's why I have not added here. Okay, so suppose if in your case you want to apply wind load on this upper shell of the tank, so definitely you need to, maybe you can just see, check what is the total maximum height. It's 20.7. So basically just go select this 1.1 and calculate the wind intensity. Just let me grab the calculator. I think I just forgot to bring with me. Okay, I will use this. So if I consider K2 as a worst condition, as a 1.01, so what will be the my intensity? So maybe I can just calculate it here, here only. 0.6 into 39 into K2 1.01 is equal to, can you calculate this? Or maybe I will calculate here.
930.94.
930 point,
94.
that is also Newton per meter square. Okay. And what is our diameter of the tank? If I go back here, this is the radius, internal radius. So can you tell me what is the external diameter if we have the wall thickness of 200? So I want this out to out dimension for the tank. 4.44, sorry, 4.405 plus zero point 0.2, correct, into 2. 9.21, that is diameter hour.
Yes, sir.
Okay, so I'm just checking uh, base shear due to wind. my intensity is 9.94 into 9.21, sorry, 9 point, how is 21? 9.21 diameter into height of the tank, 5.7, I guess. Upper shell, I'm just considering the upper shell. 5.7 plus I will consider this 750 depth. 5.7 plus 0.75. Total solid area which is going to obstruct the wind, 6.45. Got it? This is meter. This is also in meter, and this is in Newton per square meter. What is the answer? Unit.
590.48.
What is the unit? Five
Kilo-
nine.
Newton or kilonewton?
Newton.
590. 590.48 Newton.
5.94 into 9.21 into 6.45. 590. Let's say
Newton.
591. So be confident with units. So this is square meter. This is up for denominator, and this is for numerator, correct? So this square meter get cancelled, so we get only Newton.
Newton.
So how many kilonewton?
5.91 kilonewton. No.
5.
Point,
0.59.
0.5. 0.5.
591 divided by 1000.
Yes, sir.
591, correct? That is the kilonewton. And we have to consider, if I so we are applying wind load on this area. If I want to see in the plan view what we are applying, so this is the exposed area, correct? If the wind load is applicable to this, so what we are doing, wind load will be applied to this exposed area of the upper tank. And obviously what will happen, so this is windward face, but wind will be also applicable, needs to be considered for wind leeward also, correct? So there will be some different coefficients, correct? So agree, this is the windward face and this is the leeward face, so we need to consider this effect also. And we are still missing to apply the loading on these vertical columns, okay? But what I'm getting, due to wind load, my base shear, because this is the major contributor, against the wind load, because this is a solid obstruction area as compared to exposed area of each column and each beam at this staging level, because correct, agree? So what I say, even though if I, let's assume, if I assume the same intensity will be applicable here, so what we need to do, we need to double this. So what happen if I get double this, still it will be somewhere around 1.2, correct? 1.2 kilonewton. Okay, and let's calculate the exposed area of one column. What is our size of column, RCC column? Can you quickly calculate the periphery of this 400 diameter, 450 diameter exposed area? Meanwhile, I will just bring my calculator also. So it is very difficult to calculate on this. Okay, so what is the circumference of the 450 diameter? Hello, can you hear me?
1413.
Pi 2.45, 1.14 meter, correct? So we will just see area of one column equal to 1.4. I will make it round figure 1.42 meter into what is the height, because I want to show that we can easily neglect this. So you can see 14.25, that is the height, correct? Got it? 14.25, that is the height. So this is now exposed area for column. Now little bit we can reduce the K2 instead of 1.1, maybe we can go with 0.97, but it's fine. Go with this maximum 9.94. I'm not writing now the units, but ultimately it will come in Newton. 1.42 into 14.25 into 9.94. Actually, I need to consider half, but still okay, considering windward, leeward. Okay, so we are getting only how much? 1.42 into 14.25 into 9.94. So 201, let's say 202 Newton. So it comes as a 0.2. 0.2 kilonewton into, I will just multiply total numbers of column. How many numbers column are there? 9. So I will 9 columns. Okay, C 9, that is the maximum. So I will multiply into 9 numbers. So 0.2 into 9, 1.8. So even though I will just add some of the exposed area for the beam. So what happened? So it will not go beyond the wind base shear that we have calculated for the earthquake. So what we are getting from the earthquake?
71.37.
71. So wind base shear from wind is nowhere, if we want to compare. So what you can say? So earthquake, a base shear due to the earthquake is predominant and is governing over the wind loads. So in my analysis, I am not considering wind loads. Okay. And suppose if in your case, maybe your wind load is governing, then what you can say? So in my analysis, my wind loads are governing. So henceforth, I am not considering anywhere my earthquake forces. So vice versa. So just calculate you can just add statement. You can just add statement somewhere giving references. Governing lateral base shear due to earthquake is 72 kilonewton, which is greater than base shear due to wind load. Maybe you can add your value. Suppose if I see what I can add this, so 0.591 plus 1.8 plus maybe somewhere some wind loadings for the beams also. So maybe I will add the same intensity 0.8, 3.8, even though I say, let's say 10 kilonewton. So that is also very on higher side, but just for I want any number, that's why I'm just adding 10 kilonewton. So wind loads are not okay, vice versa. So based on your intensity of the base shear, you have to just change your statement. All good till now? Okay.
Yes, sir.
Okay, then analysis part will be the same as everything. So upper part, so what your intention, you have to find out the design moment, design values like moments, tension, shear force for the upper part, the wall. Okay, those things are same. You can consider the same thing for the circular tank. So I will directly go to the results. So we already know this is again added the picture, local X, local Y, MX, which one is the MX, just for your information. Analysis of the structure, the plate orientation, same thing that we have already gone through. Okay, now and tension, hoop tension, how we can find out from the. So if I consider this my upper container, so I added this picture. So MX, MY, this is selected plate. So for this plate, what I'm getting, maximum MX as a 2.19. For which load combination? For dead load plus live load combinations, 2.71. So this is very basic. Actually, we don't need to go such a deep level, individual level, because in this report, this is we have shown this for each and every plate for every load combination. So this is MX 2.9 at somewhere around mid level, that is a maximum. Okay, -2. At top, what is the value? We are getting 0.85. Now SX, that is a tension force. What we are getting for dead plus live load, that we are getting 1.05. So same thing. How to calculate? Just calculate the maximum tension. We already gone through that. Maximum tension into wall thickness. Maximum tension into wall thickness. Wall thickness, why? Because we are considering only 1 meter, that is the by default, and wall thickness, that is a 200. So you will get the maximum tension force, that is into kilonewton. Okay, so same thing for different load combination and different places. We are we are just trying to extract. But I recommend just go and find the maximum, do only once, and go for that maximum thing. Like here we are getting maximum tension and 210 kilonewtons. So there is absolutely no need to find out these other places because it's giving less values. So obviously your design will be for 210 kilonewton. If you want to reduce some, save some steel, definitely you will go with this. But first I recommend just go with the uniform. Once you are uh, uh, you know where we can save the things, still yes, we can little bit reduce or try to optimize your reinforcement. Okay, here we are getting 107. So what can, maybe someone can provide 12 bar diameter at 100 somewhere around top, the intensity tension is less. So maybe you are going with the same diameter of bar, but you can increase the spacing, so that can take care. So based on that you can little bit provide some economy optimization also. But make sure that during the construction you have to be very careful for the placing of the placing means spacing, spacing of the reinforcement. So sometime it will be good if you go with the some uniform spacing, so it will be easy for construction and for checking. Okay, if the size is very less, okay, some if the tank height is only 1 meter, so there is no need to change the spacing. Okay, so now the same spreadsheet that you have to just enter all these values. You will get all the design parameters like reinforcement, crack width. So everything will be, you will be get through that spreadsheet. Okay, so those spreadsheet, the photos from that spreadsheet are pasted here. Okay, now this is for the base slab. We are trying to calculate the my. So maximum values for my, same with the maximum values for this. Last time we have, this time we are trying to find out the mx for this plate. If we are going close, so this is 37. So just go with two only cases, this plus 37, that is a positive, and minus 48. So consider only these two figures, your design will be done. Okay, same thing for this also. So we have just checking the crack width whether it is okay or not. This is the cantilever walkway. We are checking the bending moment for this maximum bending moment for the cantilever walkway. Roof slab, mx, my. So same thing like is repeating. You have to you have to calculate mx, my for base slab, top slab, wall. Okay, you have to calculate tension for only vertical walls by finding out maximum sx or x, sy. Based on that, your local orientation, whether it is sx or sy. Okay, so based on that, if you find out all these things, you are done. And I'm going to one more thing. Someone say I don't want to use the Excel sheet, then how to calculate manually? So these pages are very important. So let's say Avinash will say I don't want to do it manually, I want to go with the manual calculations. Yes, absolutely. And for initially I also recommend don't touch that Excel sheet. Take pen, take a notebook and do it manually. So from start, if we get all these hoops, tension force, maximum bending moments, so within this only couple of pages you can do your all the calculations. Okay, so wall reinforcement calculation for circular bars at the bottom. So I will just show the procedure. don't focus on the numbers, because numbers can be changed for each structure, but just remember the procedure. Okay, so what is the effective depth? How we can calculate? Because the wall thickness is a 200, so what is the clear cover? Maybe we will consider 20 mm and diameter by 2. Okay, why we are considering diameter by 2? Because this is my wall, this is my reinforcement, vertical reinforcement, and this is the my horizontal reinforcement. Okay, so this is clear cover, and actually I need to show the thickness for bar also. Try to assume this is a cross section or elevation for wall. I'm trying to show this as a bar with some thickness. Correct. This is my horizontal reinforcement. Now this is my clear cover, and if I consider effective depth from any side, if you're talking from this side, then what we need to consider this total D minus the center. So for that, what we need to consider, the effective cover minus half of the diameter. If you are calculating the vertical reinforcement bending, if you are calculating the horizontal, then what you need to do, this cover plus full diameter of this bar and half diameter of the horizontal reinforcement. So values will be little bit change, but sometimes it matters a lot. Okay, so just consider that. So how to calculate if wall effective D, wall thickness minus clear cover minus half diameter. So assume if we are using the 12 mm bar diameter, so based on that, this 200 total wall thickness minus 30 mm clear cover and 12 by 2 half diameter. So what is my effective depth? That is a 164 mm. Okay, from start, if I getting maximum moment is 4.07, and Sx, that is a tension, that is 1.57 Newton per mm square. Okay, how to convert that tension into the kilonewton? So area into thickness, same thing, 1000 into 200 into 1.57. So it gives us an Newton value just converted into 315 kilonewton. So now I want to calculate the moment for this, for tension and for this moment. Okay, so how to calculate? So before that, even though sometime we have to check the minimum reinforcement based on the codal provision, even though moments are very less, tension is also very less, but as per code I have to provide some minimum reinforcement. So for that is we can calculate as a 0.24 by 100 into 1000 into thickness by 2. So based on that codal provision, even though based on that bending moment tension, minimum reinforcement I need 240 mm square. Okay, so this is the minimum reinforcement. Now for the attack of this, I have to find out the reinforcement required. So what is the formula? You must be know this during our academics. In our exam paper also we have used this formula many times. Okay, so what is that? AST is equal to 0.5 FCK upon FY. FCK means grade of the concrete, FY means grade of the steel, into 1 minus under root of 1 minus 4.6 mx divided by FCK B D square into BD. So we have all the values, just put those values and find out the reinforcement. Okay, so if I put all these values, 4.6 into my this moment 4.07, in why I created this 10 raised to 6, because everything is in mm. Okay, that's why I have added this 10 raised to 6 to convert that bending moment from kilonewton to Newton per mm. Okay, That's why I have just added as a 10 raised to 6. Got it? Otherwise, it is very straightforward because grade of the concrete is 30 Newton per mm square. This is also tension. Grade of the steel 500 Newton per mm square. B, we are always considering 1 meter strip, that is the 1000. And D, that we have just calculated 164 mm, so that is the 164 mm. So calculate the reinforcement. So for bending moment, I need only 57.44. So again, just compare this, whether this is greater than minimum or less than minimum. So it is less than. So definitely I have to provide 240 mm square. Okay, correct. So this is governing. Now this is just for the bending moment. Now check for hoop tension, what reinforcement that we need. Okay, due to hoop tension, we already calculated the T and sigma st, that is a allowable stresses in steel. Okay, so again we have converted this kilonewton into Newton by adding 10 raised to 3, and this is the 0.87 into 500. So for AST, due to the hoop tension, I required 70 724.92. Let's say it's 725. Okay, so just make this addition, 725 and 57. So it is required 782, which is greater than 240 mm. So provided required steel is greater than AST minimum, that is okay. Now how to calculate, how to provide the, how to fix the spacing. I know I need this. This is the steel required, and we are going with 12 bar diameter. But how can I space it? So to find out the spacing, what is the formula? This is the area of the steel, pi by 4 d square into divided by required steel into 1000. Okay. So now you can just check. This is the area divided by required steel into 1000. So spacing, that is I'm getting as a 144. So is it practical spacing? No. So maybe you can go with the 140, or if I will be there, so maybe I will use 125 mm. Not because this 140 is also somewhere not common spacing on site. Maybe 100, 125, 150. Even 125 is also kind of odd spacing. If I will be there, so I will choose the 100 mm spacing. Okay. So okay, 140. So provide 12 bar diameter at the about 140 spacing. So what we are providing, just that check also, pi by 4 d square divided by spacing into 1000. So we are providing somewhere around 807 square steel, and as against we required 782 steel. Okay, so this is obviously greater than that. Okay, so fine. So we are safe. So what we calculated, this is at a bottom, means this is for negative steel. At middle, obviously we have some change in the bending moment. So same procedure, just change the bending moment number, change the uh, hoop tension number. You will get the spacing because we are providing same bar diameter 12 So at mid, we are getting spacing 240, 165. So if you want, yes, you can try to reduce that. And if you go at the top, so let's say what we are getting at top, we are getting 12 bar at 275 spacing. Okay, so this way you can calculate your spacing manually also without depending on any Excel sheet. And this is the basic things. This comes from the basic principles, whether it is circular, whether it is rectangular, any kind of, because these formulas are calculating the reinforcement. So we have to just input is only the bending moments, whether it is for the circular, rectangular, or any international shape. Clear? how to calculate reinforcement manually.
Yes, sir.
All good?
Yes, sir.
Okay, so this same thing, we are just repeating for each element. So you have to calculate this for many times for different types of element: wall, base slab, roof slab, uh, column, okay, beams, vertical bar. So nothing, same thing is repeating again, like the clerical things. And after that, I have just added the stat file. So someone want to check what I have did in the stat. So for his reference, you can just paste all your stat file here. So he can just copy everything and just paste it in new stat. So he can get ready-made stat file that is you have used for your design or your analysis purpose. Okay, this way we have completed our elevated reservoir, storage reservoir, which includes design. And the most unique part is the different part is different and difficult part includes the earthquake analysis, how to consider. Otherwise that is only little bit different than otherwise everything is same with the circular tank. Okay, got it?
Yes, sir.
Okay, so I will now start it on the STP. That is our last chapter for water retaining structure. Okay, this is also very quick and simple. So this is a design basis report for proposed sewage treatment plant, that is called STP.
So
So
this sheet will be uh, 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 given us for this one.
uh, means
So
I'm
this
not able to.
design sheets will be shared with us. No, sorry, in
Yes,
the mail.
yes, yes. Okay, so we will start with the basic of the project. So functional requirement, that is obviously a sewage treatment plant. Capacity of the water tank is I guess it's 250,000 liters. Okay, fine. Diameter of the tank 4 meter. We have this tanks some here. Those are 4 meter tanks. Height of the tank is 4.2, including freeboard. Before that, excuse me. So what is the STP? So STP is a combination of different structure comes under the any treatment plan. Okay. So suppose this is my entire plan. Under this, there are different types of the tanks which is designed for the process of the any water. Okay. So if you see this, so you can see there are different names of the different tanks: equalization tank, sludge holding tank, treated water tank, intermediate storage tank. After that, a tube settler, aeration tank, anoxic tank. Okay, so what is the function? Basic function is obviously there will be some inlet of the water. From that, the polluted water will be come into this tank, and we have to do some different types of process on that water. So and finally, the output will be the clean water that we can be used for the recycling, or maybe we are using that water to be treated and it will not be harmful to the open environment. Okay, or maybe we can drainage it out into the river. So, okay, so all we are the contaminated things that we are in that water we are taking out, so that we are the processed water can be get out from the tank. Okay, so at most of the tanks, yes, so these kind of the things are there. But so, and basically all this entire process will be designed by the chemical or the process engineers. Okay, so if we are considering in terms of the in perspective of the structural engineer, so that is our that is not our point of focus, but our point of focus will be what is the sizes, what is the end-to-end sizes of this tank, what is the water direction from where it comes, and what is the different operation methods, and from where it comes and from where it goes out. Okay, so that is only main intention, otherwise everything taken care by the process engineer. They will give you all these volumes, sizes, so don't worry about that, because for that there is a different kind of special requirement. So it's not our job basically. Like architect will be design and give you the sizes, and after that you have to design. So same thing, our intention, we have to design all these structural elements to support the process function. Okay, got it? So if someone asks me why this tank here, so I also don't know, but I will make sure that if tank is there, so definitely that tank will be safe based on this water load for any worse loading condition. Okay, that is my basic function as I'm working as a structural engineer. Okay, and definitely yes, for that I need to know how the water is coming into the tank or this tube settler. So that is my area of interest. Definitely I need to know this, otherwise I cannot apply the loadings. Okay, so if you see this, there are different types of tank which are clubbed, and all entire things are comes under this one treatment plant, that is called as a sewage treatment plant. Okay, got it till now? Any questions? All good?
Yes, sir.
Okay, so height of tank is 4.2 meter. Okay, construction type same thing. I'm using M20. Grade of steel is 500. Design for philosophy, yes, so all are water retaining structure designed by uncracked or maybe 0.2 mm crack thickness, crack width. All the codal provisions, which codes that we have used, part 1, part 2, part 3, part 4 of IS codes. Foundation data, obviously we need basic soil safe bearing capacity. Okay, I am not getting the subgrade modulus, but from this data I can find out by considering some allowable deflection. Okay, we also know that how to calculate that safe bearing capacity. Based on that safe bearing capacity, how to calculate the modulus of soil which can be applied to the base slab. Okay, which acting as a support to the base slab. Okay, soil type, silty and sand gravel standards, IS code. Okay, dead loads, so superimpose dead loads. So if you do with this your STAD model, all self weight from of all each element, all and each element will be taken automatically by STAD. But in addition to that, yes, if you want to add some additional like water chemical proofing or some kind of floor thickness, in circular tank also we consider this screed. I think in circular we consider 40, here we are considering 50 mm thick. Okay, live load, that is comes with the water load, and at some places yes we need to consider 10 kilonewtons. So this is as per IS code, because it's a treatment area, it's not a residential area to consider only 3 kilonewton or 4 kilonewton, because we have to assume some extra live load for some kind of equipments, machineries, and that can be shifted. Okay, so that's why we are considering 10 kilonewton. Load combination, yes, as per IS code, yes, dead plus live, that is for the service level. Yes, you can see service level. and factored, yes, 1.5 dead load plus 1.5 live load. So same thing, cover information for footing, we are assuming 50, for slab, we are assuming 30 cover. If it is a retaining wall or vertical wall, so for that we are considering 25, which is in contact with soil or water, and all water retaining structures that we can consider as a 30 Okay, material steel, it's like a density, even though you can just, you know, this very basic things, what is the density of steel, concrete, brick, blah 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 thing. Okay, water 10. Again, all the design parameters from the IS codes for grade of concrete, based on that what we are considering the allowable permissible stresses in the concrete, steel. Okay, for the steel, so those things are again added, same thing. Minimum wall reinforcement required based on the code. If it is less than 100, so we can consider as a 0.3, between 450 and 100, so 0.3 to 0.2. Okay, so detailing practices, same thing, earthquake, all the design codal references are listed. So now we will start actual analysis. So now this is interesting and but very simple. So if you see this is the plan of this STP. So what, how you can design? So obviously there are two options. Okay, you can go with the manually, because is it the circular tank?
No.
So it's a rectangular tank. Obviously, we have some dimension 14.3 meter by 8.4 meter. Okay, so by just looking this geometry, what are the different options those are generated in your mind? Can you please share with me that? How can you go and analyze this entire system? I just try to know what different thoughts that you have in your mind based on our some earlier lectures. So obviously, yes, you can go with the PCA tables, correct? Otherwise, you can go with the STAAD Pro. So these are the basic and very raw answers. Yes, I can do it manually or I can go with the softwares. Absolutely fine. But just again to refine that, even though if I go with the PCA or STAAD, what different things that I have to take consider during this analysis?
There are many units rectangular.
Correct. Correct. There are many units. So for that many units, what we need to do, just think in terms of the loading. What you see different between a single tank and a, a group of different tanks clubbed together. So what are the different probabilities, possibilities, combinations will be possible if you see this? Absolutely correct. There are many tanks. It's fine if it is different, fine. But I want some answer from you.
We can take them as SIDL.
We can take them as a,
SIDL, superimposed dead load.
okay, that is fine. But how you treat those different tanks in terms of the analysis? Again, I will little bit break it down. Okay, suppose if I go with the PC tables, so what will be the my first step? Again, so these are the my main walls, correct? I will get it into my, if I go with my PCA tables, so what I can see, there are is there any different types of wall there? Yes, there are different types of wall that you need to consider, because for STP I'm creating a combination of manual and StatPro also. So I want to make you aware that how PCA table can be used for such situations, and at the same time how you can use the StatPro. So I will suppose first I will start with the PCA table. Okay, so this is the wall. You have support here, you have support here, you have support here. Okay, so what I can do, I will assign some names. Okay, W1, this is W2, W3. These have support here, support here, support here. Neglect this portion because its length is very less. Okay, you can consider this as a one entire wall. Neglecting, it's up to you. So W3, this is small portion. W4, W5, W6. Maybe someone like to consider this as a W7, W8, and W9. Got it? This is W10, W11. This is W12, W13. Previously, and this is only the horizontal walls. What about the vertical walls? So for vertical walls, obviously, we have this support. So 13. Start W14, W15, W16. We have to consider this one also, W17. This is also we need to consider W18. This is same W18. This is same W18. Or maybe you can consider all W7. Okay. So number is not important. We have to just identify what are the different types of wall that we have based on the supports. Okay. So let's say W18. This is W4. This is also no, this we can add as a separate W15, W16, and this is same external wall, W14, W14. Okay, W15, this is also W15. W19, this is also W19. Okay, created. Understand? Number is not important. We have to identify different types of wall having different lengths, and based on that is different support condition. Got it? Last time we have only 4 long wall, 2 long walls, and 2 short walls. Give me 1 minute. Give me 1 minute. Okay. Any doubt till now? Why we are making different types of wall? All clear?
Yes, sir.
Okay. Now consider in terms of the loading. So obviously, because if you go to design this entire tank, if you go with piecing the PCA table, it will be a little bit difficult. So what we are doing, we are breaking it to different types of wall. So now if you consider different types of load, okay, so what are the different possibilities? Like the first session, we have 2 basic load cases. Which are those? Tank empty and tank full. So is that principle or is that load cases can be applied here also? Think on this. Can we apply that logic or not logic? So definitely yes. So that load cases can be also applicable here. Can you tell me how? Bhakti madam.
Some units hold water for 24 or some period,
And
and once means there are many units for aeration tank. There, I think there will be many units. One unit will be empty, one unit will be full.
absolutely. So absolutely. So I want that specific word from you guys. So yes, obviously when we design, okay, when we design or when we analyze, so we need to consider this. Okay, so during its entire operational condition, there might be possible that one tank is empty and one tank is full. We don't know. As a structural engineer, we don't know what is the purpose, what is the process. But as an structural engineer, I want to make sure my all walls are safe for at any condition. Okay, so I have to make all this loading, all permutations and combinations. So if I see this, or maybe I can use the fresh, or let's see, keep okay. So if I focus on this equalization tank, okay. So if I focus on this equalization tank, what are the different options? Okay, so if this equalization tank is totally filled with water, obviously, so you have to consider W1 with water load. This W15 also consider with water load, and this W this wall be considered for water load. But what about from the opposite side? This is external side, so obviously there will not be any water or any soil from outside. But if you consider this wall, so we have to consider many different things. Okay, this tank is filled. Maybe for worst condition for this wall, you need to consider this tank will be empty. Okay, got it my point? Then only this wall will be try to get bend this. If this is water, this wall will be, the water from inside of this sludge holding tank will be opposing this. So for worst condition, what you need to consider when I go to design equalization tank walls, I will consider this tank is empty. Okay, this tank is full and all other tanks are empty. Okay, same thing.
Yes, sir.
If I go with this sludge holding tank, what I will consider, only water is here, other things are empty. So you have a lot of load combinations, you have a lot of, you need to lot of do some different load cases. If this is fill, this is not, this is yes, this is no. So those things will be generated and you have to just write out down proper way. So even if you go with the stat or if you go with the excuse me, or with the manual calculation, so those areas that needs to be analyzed. Okay, if you analyze, then your work will be very simple. Okay, so this is only W15 was good, but what about this W5 and W6? Because W5 is get supported or this get interrupted due to this vertical wall. So maybe if you designing this W5 and W6, what you can consider, again there are two options. Okay, this is entirely full, this is empty, and this is partly, this is also full. So maybe your worst case will be like this wall is trying to bending here and I'm getting maximum moment here because here are water. Okay, same thing. Maybe this is full and this is empty. Again I need to change this. Got it what I want to say?
Yes, sir.
So this way, just we have to create a different types of load combination. Otherwise, this is very simple, easy. You have to just find out if you go with the PCA table, length, height, aspect ratio, just calculate the water pressure, and within 2 page you can done with your calculation. But that loading is very important. Okay, simple. So can you do it by manually PCA tables? Just choose one by one element, wall 1, wall 2. It's like a clerical thing, but in terms of the structural perspective, you have to do the repetition for n numbers of wall that you have identified. Okay, so wall 1 to up to wall 15 or maybe wall 20. Got it? So that is for the PC table. And if I go with the stat, obviously you have to model it. No option, you have to model it, everything. You have to model this wall, all this wall. Okay, so there is some level difference. So I have ready-made model open with me. Okay, so if I go with, I will just hide the roof slab here, or somewhere at some location there are no roof slab also, it's open. I will just see, and it's rendered view. Yes, can you see this? These 3 tanks are open and this is the close. These 4 tanks are closed. Okay, if I go to plan view, I don't want to see supports. I want to select all the walls. Plates. Oh, this old version not giving the walls, select walls parallel to right side or X, Y. Plates parallel to. I'm not getting the plates parallel to. Definitely you have that option during in select. If you go select plates parallel to, but okay, fine. You can see this. This is the equalization tank. Equalization tank, sludge holding tank, and treated water tank. Okay, equalization tank, sludge holding tank, and treated water tank. There are some small segments. 1, 2, 3. Hope you can see this. I will try to make on all these wall thicknesses also full section. No, for plate it's not possible. Okay, then if I come back to this anoxic tank, aerator tank, and tube settler. Anoxic tank, aeration tank, tube settler, and intermediate storage tank. So basically it's box type of different tanks I just clubbed together. And the main different things, that is the load combinations. Okay, so main things are, otherwise is it is totally same thing, similar to the rectangular tank. If I go to the load combination, so that is only different. Where is that load combinations? Okay, Dead load, yes. So self weight will be taken care by all the STAD by automatically STAD. I have applied the superimposed load, that is the waterproofing things or those things are added. Live load also applied on the floor, roof slab, on the outer walls. I have selected as a outer walls, created outer walls. And after that, what I did, I created some different combination. Tank 1 to tank 7. Okay. Tank 1 to tank 7. If I go to the tank 1, 2, 3, 4, 5, 6, and tank 7, I created different tanks and applied the water loads for all walls. It's very simple. I know what is the maximum height of the water, and I have applied all the water loads to the tanks. Tank 1 to tank 7, same thing, nothing different. Till now, okay. If it
Sir,
is soil, hmm,
for this sewage density will be different, right?
very, very likely.
Okay.
And what we are considering, actually density of the water is 9.81. So we are always considering the 10, even though it's a sewage, so its density is less than 1, less than 10. Hardly there is a change in the density.
Okay, sir.
Okay. So what we are doing, we have identified different tanks and we are just applying the loads fully. Okay. If there is soil outside, yes. So if it is underground, yes, we have applied the soil also, and that is obviously from the outside. So that is only one case. Now the most interesting part is, what will the first case? Tank full. Correct. Tank full, no soil. But again, we have to subdivide this in different steps. There is a possibility that yes, entire tank is full. Is it possible? All 7 tanks will be get full. Is it possible or not possible? Yes, it's possible.
Possible,
During,
sir.
yes. So this will be the first case. Entire tank will be full. I don't know, but this can be a case. Okay. So that's why what I did, I created first load combination as a tank water full condition. So in that case, what I just added, you can see this. Obviously, dead load, live load will be always there for all tanks. But after that, 1, 2, 3, you can see this. From 1, 2, 3, all I have added from 5 to 11, because from 5 it will start tank 1 to tank 7 till 11. So you can see this 5, 6, 7, 8, 9, 10, 11. So under this load case, what I'm considering, entire water tank will be full from each side. Okay. Then now what I am considering, what will be the second case? Very simple. Full tank is empty. Okay. Tank is empty. So what I'm considering, obviously dead load, live load will be there, superimposed load. So 1, 2, 3 will be there. 1, 2, 3 will be there. What will be the, no, this one, tank empty condition, 1, 2, 3 and 12. That is a soil outside. 1, 2, 3 and 12 soil outside. Clear? Tank is empty. No water inside, only outer soil load is there. So these are motamoti 2 water load combinations are done. Okay. Now the real interesting part will be start. Now just take a note and just mark tick. This is done. This is done. So now the what is the first? Tank 1 is full and soil from outside. Means what we are considering? Tank 1 is full and all rest tanks are empty, but there are soil from outside. What I'm just clicking here, if I go this, I will check this use. This is only full with water. soil is there, and all tanks are empty. Okay, what will be the next? Tank 2 will be fully, all other tanks will be empty with full water, full soil. If I go to the next, can you see this? Tank 1 is full. 1, 2, 3 will be common for all. 5 means our tank 1, and soil 12. 1, 2, 3, 5 and 12. 1, 2, 3, 5 and 12. So now I will just change the tank number. Tank 2, 1, 2, 3, 6, 12. Now next, tank 3, 1, 2, 7, 12. So such a way that you have to just change the tank number. Okay. Tank 4, tank 5 till tank 7. Got it? Till tank 7 it is clear. Tank 1, 2, 3, 4, 5, 6, 7. Any problem till tank 7? We are just touching one tank at a time with soil outside. Agree? Okay, so now I will have some another combinations, like from load combination 22. What I am assuming, tank 1, 3, 5 full and rest of the tanks are empty. Means if I go 1, 3, 5, 7 full and soil also 1, 3 and 5. 1, 2, 3, 5. These are the full and tanks are empty. So there are different permutations and combinations. Now next, tank 2, 4, 6 are full and so full soil outside. Because of this, what happened? Some of the walls that I am considering only water load from one side, like here I mentioned. So this tank full, no water, or maybe this tank full, this is also full, no water here. So I'm trying to get maximum effect on each wall from any one direction. That is my intention. So I am make sure that my wall is designed for the maximum possible worst condition. Out of this combination, I'm not keeping any combination, or no, I'm not missing any probable combination. That is the only thing. Okay, so like this, tank 2, 4, 6 full, again tank 1, 3, 4, 6 full. Possible, maybe there might be possible that maybe I can miss someone, but you can think, yes, this you, and so if you find if I miss anything, definitely you can also add, yes, this also can be possible. Very good, and just add that. So this is up to load combination number 26. What we are assuming, some of the tanks are full with soil outside. Now again, start with the tank 1 full, soil empty, no soil. Same, tank 2 is full, no soil, same thing. But now we are skipping the load case number 12. Previously we have considered soil, now we are repeating same thing but without soil. Got it? Same thing we are just repeating. Now this is in group 1, 3, 5, 6 full, no soil. 2, 4, 6 full, no soil. 1, 3, 4, 6 full, no soil. Same thing. Got it? The main important is to create a different types of load combination. Otherwise, it's absolutely a rectangular tank. Nothing like that. Okay. Once you are done, you can analyze and extract the results. If I go in my design report, this is the basic thing. We can just know, now we are used to with this. Just multiply height of the water into density, you will get the load on the wall. So same. Now just I show you W1, W2, W3. Find out the results for the worst condition. if like this, if I go this W1, W2, W3, got it? So this is maximum positive bending moment at somewhere mid span. This is maximum negative moment at center, because what we are getting this negative, because this partition wall like this wall is acting as a support to this horizontal wall. Okay, that's why we are getting some different types of stress contour. Okay, this is positive, this is negative. So this way you have to find out bending moment, shear force for all the walls. Like this is for only W1, W2, W3 up to W19 or whatever you have identified different types of wall numbers. You have to find out the results. Okay, so once the results are with you, just go and use that Excel sheet and calculate the reinforcement. If you don't want to you go with that reinforcement, just go and do it by manually also. I have just given one example. Same thing, effective depth. We are considering cover 200 mm wall thickness, bending moment is this. And remember, this is a circular, not circular tank, this is a rectangular tank. So obviously there will not be any hoop tension. So we have to just calculate the vertical wall reinforcement and horizontal wall reinforcement. So this formula is irrespective of vertical and horizontal. You have to just change the bending moment for whether it is vertical my or mx. So otherwise you are done. Okay, very simple, straightforward, but you have to very focus during a sign of different types of wall, and you have to be very sure, you make sure that you have not missed any possible load combination. Otherwise, if you miss any critical load combinations and just go without that, maybe for that missed load combination your wall will govern, and during the construction it will might be get failed. So main intention, you have to cover all the load combination. That's it. Okay, any questions?
सर
Hmm?
सर्कुलर टैंक में आपने आपने जो हाइट लिया था 4.1 लिया था, फिर उसको आपने लॉन्डर से माइनस किया था 0.8, उसके बाद भी आपने जो लोड अप्लाई किया था 41 किलो न्यूटन किया था। लेकिन सर जब वहां पर हम लोग 8.2 कर दिया, नीचे हम लोग 32 नहीं कर सकते हैं, 3.28 आया था तो उसका लोड, क्योंकि दोनों लोड को अगर हम ऐड करते तो 49 चल जाता है। ऐसा डायरेक्ट अगर हम लोग करते तो 41 किलो न्यूटन आना चाहिए।
And can you please repeat, because you jumped from STP to clarifier? Just I need to recall something. So what is your question?
सर सर्कुलर टैंक का जो हाइट था 4.1 था,
4.1 था,
हाँ,
करेक्ट, ओके।
उसमें से लॉन्डर माइनस कर देते हैं 0.82, ठीक है। तो वो जब वहां से ट्रायंगुलर कटा, रिमेनिंग जो हाइट बचा सर 3.28 बचा। तो लेकिन सर उस 3.28 बचा, उसमें हम लोग जो लोड अप्लाई किए हैं 41 किए, वो क्यों?
यू टॉकिंग अबाउट इंटरनल वाटर प्रेशर?
यस सर।
नहीं, we have to distribute that. So if I go, लाउंडर हमारा अंदर था या बाहर था?
लाउंडर सर बाहर था हम लोग का।
Okay, so your question is why we are providing up to top, correct?
यस सर।
Okay, so during test condition, maybe what I can consider. So I want to consider all wall up to the top. Okay, that's why we have considered up to full height.
ओके सर।
The main thing is when we are testing the tank, we always feel. प्रैक्टिकल में कैसा होता है अविनाश जी, कोई भी नया टैंक कंस्ट्रक्शन किया, ओके,
यस सर।
तो ये टैंक है, सपोज ये अपना कंस्ट्रक्शन हो गया, वेदर इट इज अंडरग्राउंड और अबव ग्राउंड, ठीक है। अगर अंडरग्राउंड होता है तो क्या होता है कि ये टैंक यहाँ तक वाटर भरते हैं, इट विल बी गेट फिल्ड विथ वाटर, ओके।
यस सर।
हाँ, and it based on that specification maybe 10 days 12 days it will get checked कि भाई कितना पानी नीचे जाता है, okay, even though it is underground it will not, soil will not get filled, so यहाँ से we have the scope to go and inspect, so if there is any leakage we can just check, okay. So during that case what we need to consider, we have to consider full height water load, okay. Now coming back to this STP, so all good with the STP? Any question?
सर इसका मॉडल बहुत कॉम्प्लिकेटेड बनेगा फिर?
नहीं, सिंपल है, जस्ट गो विद 1 by 1, बहुत ही सिंपल है मॉडल। क्या इसमें, if I go to this plan, rectangular always simple, उसमें कुछ भी नहीं है। You just need to know internal dimension, okay? एक कॉपी करो, ये वॉल कॉपी करो, हो गया। ये वॉल क्रिएट करो, उसके बाद ये वॉल कॉपी, एक्सटर्नल कॉपी करो। फर्स्ट यू जस्ट फिनिश ऑल द एक्सटर्नल वॉल, देन आइडेंटिफाई दिस, इतना कॉपी करो, और ये डायमेंशन फाइंडर उसको पेस्ट यहाँ पे करो। उसके बाद ये डिस्टेंस अगर आपको मालूम है तो इसको कॉपी करके यहाँ पे रख सकते हो, हो गया। फिर उसके बाद ये पार्ट इसको कॉपी करके यहाँ पे तुम पेस्ट करोगे तो ये हो गया। सिंपल है, अरे रेक्टेंगुलर टैंक कितना भी हो, बहुत ही सिंपल है। कॉपी पेस्ट कॉपी पेस्ट कॉपी पेस्ट, कुछ नहीं है इसमें। ये बस विजुअलाइजेशन होना चाहिए, ये कैसे मैं कर सकता हूँ। मैंने ये बेसिक बॉक्स किया, यहाँ पे मैंने बस आइडेंटिफाई किया यहाँ कितना है, ये उठाओ इसको, या अगर सपोज ये 7 मीटर है तो इसको कॉपी किया मैंने 7 मीटर पे, हो गया। ये 2 मीटर है, इसको फिर सिलेक्ट किया मैंने, कॉपी किया 2 मीटर पे, ठीक है, 3 वॉल हो गए। ये 3 मीटर पे, इसको कॉपी किया 3 मीटर। सिंपल है, बहुत ही सिंपल है। Okay, maybe we are on time. So this way I have completed all the syllabus which are given to me under the water retaining structure. So if you have any doubts, questions, so you can reach out to me
सर
through email, or you can give me a call on Saturday, Sunday. So definitely I will be there to help you in terms of any questions, any doubts, we can discuss.
सर एलिवेटेड वाटर टैंक का मॉडल पर उस पर एनालिसिस नहीं करिएगा? ये हम
नहीं
लोग
किया ना हमने, रिजल्ट तो सेम ही है, जो सर्कुलर है सेम है।
सर एक बार कर देते तो ज्यादा बेटर।
Same, nothing is different. Maybe you will try. If you have any problem, definitely we can contact, okay.
Sir, how to contact you, sir?
Last time I have given my email ID.
Okay.
सर 1-2 क्लास में वो कर देते मॉडल से, बाकी एनालिसिस का हम लोग देखते हैं। वो
Maybe you can check with madam, so that can be checked with Anil sir if it is okay. I'm ready because I have assigned with something, so during that I have to finish, okay. And sorry because in last Monday we cannot meet due to some personal things. Otherwise I'm planning to finish everything by Monday, this Monday.
आपके तरफ से कोर्स कंप्लीट हो गया सर?
वाटर रिटेनिंग का yes.
क्योंकि अगर वो कर देते तो हम लोग ज्यादा बेटर रहता। फिर अगर टाइम नहीं तो सर एक हमारे अगर जो एलिवेटर वाटर टैंक का जो वीडियो अगर पहले का जो आपके पास हो वो मेल करवा देते, उससे हम लोग देख के मॉडल पर एनालिसिस कर लेते प्रैक्टिस के लिए।
मतलब मैं कुछ समझा नहीं, पहले का वीडियो
मतलब पहले का वीडियो सर जो क्लास लिए होंगे एलिवेटेड वाटर टैंक का, उसका जो मॉडल एनालिसिस करके रखे होंगे रिकॉर्डिंग क्लासेस।
नहीं, मैं एलिवेटेड वाटर टैंक का मैं सेपरेट ऐसा एनालिसिस नहीं करता, क्योंकि दैट्स व्हाई वी स्टार्टेड विद द सर्कुलर टैंक, ओके। अगर हमने सर्कुलर टैंक किया तो सेम थिंग वहां पे भी है, तो उसमें कुछ अलग नहीं है ना। अगर if I started with elevated water tank तो it will be difficult to understand, क्योंकि earthquake में पूरा सब फोकस चला जाता है स्टैट मॉडलिंग के ऊपर. स्टैट मॉडलिंग इज अ वेरी बेसिक थिंग. इफ यू कंसिडर अ वेरी बेसिक कॉन्सेप्ट, सो स्टैट मॉडलिंग इज आई कैन कंसिडर वो बहुत कुछ इतना मुश्किल नहीं है. लेकिन जो मैंने पढ़ाया बेसिक, वो अर्थक्वेक फोर्सेस क्यों आते हैं, कैसे आते हैं, दैट इज मोर इम्पोर्टेंट. व्हाट आई ऑब्जर्विंग, यू आर मोर ओरिएंटेड विद द स्टैट, लेकिन वो कंसेप्ट को पकड़ो. स्टैट तो बात का है कि बेसिक लोड स्टैट आप एक्सपर्ट हो सकते हैं अविनाश जी, लेकिन जो अगर कंसेप्ट आपने मिस किया ना तो दैट विल बी वेरी डिफिकल्ट.
प्रैक्टिकल चीज सर वो तो है, आप सही बोल रहे हैं, लेकिन प्रैक्टिकल चीज पर ज्यादा आदमी फोकस करता है, वो ज्यादा समझ में आता है. जब अप्लाई हर चीज कीजिएगा आप, तो वो देख के भी आदमी बहुत कुछ कंसिडर करता है.
फोकस ऑन बेसिक्स.
वो सही है सर, फोकस ऑन बेसिस सही आप कर रहे हैं, बट लेकिन जब कोई चीज प्रैक्टिकल आदमी सामने से करता है, तो आप जैसे करते हो आदमी को ज्यादा समझ, किसी को भी समझ में वो चाहिए. मेरे साथ तो यही पॉइंट ऑफ व्यू सर, कि सामने वाला क्या कर उसे थोड़ा देख के कंसीडर बहुत कुछ हो जाए प्रैक्टिकल में, इसीलिए बोला.
करेक्ट है. maybe you can just check with Pragya madam, and so if we can fit those sessions, definitely we can just go ahead and finish those things.
मैं भी बात करता हूँ सर एक दो क्लास के लिए, क्योंकि एलिवेटेड का हो जाए और इसका तो
ठीक है ना, मुझे कोई प्रॉब्लम नहीं है. आई एम ऑलवेज देयर. ओके
ओके सर.
I think all good. Then maybe we can stop here, and it's always good to see you here, and thank you for listening me. Hope all these interaction sessions will be helpful, and you will have a great future with all your structural, based on this structural syllabus. And I'm wishing you all very best in your future professional life.
Thank you, sir.
Thank you.
Thank you. Bye. Good night.
Thank you.
Good night, sir.